This circle. You've probably been drawing this shape since you were a kid, right? So simple, so perfect. But what if I told you it's got this secret language? A whole set of hidden rules just waiting to be found. Well, today we are absolutely cracking that code. So what are we even talking about here? What are these secret rules and relationships hiding inside what looks like just a simple shape? How do basic lines and angles start acting differently the second they're inside that perfect circle? Well, that's exactly the mystery we're going to solve together. Okay, so every good journey needs a map, and this is ours. To unlock the circle's secrets, we're going to follow these clues. We'll kick things off with chords, then we'll move on to arcs, and finally we'll tackle something with a fancy name, a cyclic quadrilateral. Think of each one as a piece of the puzzle. All right, first stop on our journey, secrets of the chord. Now this simple little line, it is the key. It unlocks so many of the circle's secrets. If you can master the chord, trust me, you are well on your way to cracking the whole code. So what even is a chord? It's really, really simple. It's just a straight line where both ends touch the edge of the circle. That's it. It could be a tiny little line or a big one that stretches almost all the way across. But the rule is its endpoints have to be on that circumference. Sounds easy, right? Oh, but don't let that fool you. This simple line is capable of some pretty amazing things. Okay, let's play a little game. What do you think happens when a line coming right from the center of the circle meets a chord at a perfect right angle? I mean, a perfect 90 degrees. Take a guess. What happens to that chord? All right, let's see it in action. First, you draw that perpendicular line from the center. It hits the chord at that perfect 90-degree angle. And then, look at that. It cuts the chord into two exactly equal halves. Not sometimes, every single time. And that, my friends, is our very first hidden rule. The perpendicular from the center always bisects the chord. I mean, it cuts it in half, guaranteed. Consider that the first piece of the circle's code, officially unlocked. But chords don't just sit there, you know? They also create angles. Now, here's a key idea. The angle subtended by a chord. All that means is the angle you get when you connect the two ends of the chord to some other point on the circle's edge. It's kind of like the angle the chord sees from that spot. Now, this is where it gets really cool. Chords create these angles, right? Well, it turns out that angles that are in the same segment of a circle, they're always equal. You can move that point anywhere you want along that part of the circle, and that angle, it just doesn't change. It's a constant. A rule you can absolutely count on. And it gets even better. There's this beautiful symmetry with chords. Check this out. If you have two chords that are equal in length, then they're going to be the exact same distance from the center. But here's the kicker. It works the other way around too. If you find two chords that are equidistant from the center, you know for a fact they have to be the same length. It's this perfect two-way street. Okay, so we've got a handle on chords. Now let's shift our focus from straight lines to the curved edge of the circle. Let's talk about the power of the arc. And believe me, the rules we're about to uncover here are maybe even more powerful. So, what's an arc? Super simple. It's just a piece of the circle's curvy edge. Its circumference. Could be a tiny little curve, could be a huge one that wraps almost all the way around. And just like its straight line cousin, the chord, an arc can also create angles. And its rules? Oh yeah, they are just as fascinating. All right, get ready for this next one because it's an absolute game changer. Here it is. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. I know, it sounds a little formal, but the idea is incredibly powerful. Let's break down what that actually looks like. Okay, look, you've got an arc, right? It forms an angle right there at the center. Now that same arc also forms an angle way out on the circumference. And here's the magic rule. The angle at the center is always double the angle at the edge. So, if that angle on the circumference is, say, 30 degrees, the one at the center is guaranteed to be 60. It's that simple and that powerful. Okay, let's start to bring all these ideas together now. What happens when you draw a four-sided figure, a quadrilateral, but you draw it so that all four of its corners are touching the edge of the circle? Well, that gives you something called a cyclic quadrilateral. And you guessed it, this very special shape has its own very special rule. And that special rule all comes down to one magic number, 180 degrees. So what does that mean? It means that in any cyclic quadrilateral, if you take the opposite angles, the ones directly across from each other, they will always add up to 180 degrees. It's an unbelievably consistent and powerful property. It works for any four-sided shape you can possibly draw with its corners on a circle. So there you have it. We followed the map, we tracked down all the clues, from chords to arcs to those cyclic quadrilaterals, and now I think we can safely say we've done it. We're cracking the circle's code. And here it is, the code all laid out. Let's run through the secrets we've uncovered. 1. A perpendicular line from the center will always cut a chord in half. 2. Angles in the same segment are always equal. 3. If chords are equal, they're the same distance from the center, and vice versa. 4. The angle at the center is always double the angle at the circumference. And 5. Opposite angles of a cyclic quadrilateral always add up to 180 degrees. That right there, that's the secret language of the circle. So now that you know the code, where are you going to see it hiding in plain sight? The next time you look at a bike wheel, a pizza, or even the moon, remember, it's not just a simple shape. It's this incredible system of beautiful hidden rules. Look for them out there in the world, in art, in architecture, in nature. Because now you know the secret. The code is everywhere.